This Pyrochrome chromogenic training video will help you achieve testing proficiency with Associates of Cape Cod's Pyrochrome reagent in the kinetic format using our incubating Pyros Kinetix Flex tube reader. Prior to running the assay, ensure that you have all of the materials necessary to achieve a successful test. These include LAL reagent water, LRW, dilution tubes, borosilicate glass tubes, pipette tips and syringe tips, such as Eppendorf combi tip, and optional glass serological pipettes. Adjustable pipettes will be used for transfer of liquids of various volumes. All accessories and reagents should be certified free of interfering levels of endotoxin and glucan contamination, such as those available from the Associates of Cape Cod's PyroClear line of products. A vortex mixer will be used for mixing solutions used during testing. Parafilm will also be needed to cover the tops of containers. Test tube racks are needed to hold dilution tubes. These products have to be purchased separately. They are not supplied with the Pyrochrome kits. Let's begin by examining the contents of the Pyrochrome reagent. Kinetic assays with Pyrochrome reagent can be performed with two different kits, either with Pyrochrome reagent and Pyrochrome reconstitution buffer, or with Pyrochrome reagent and glucoshield buffer for reconstitution. The glucoshield buffer is used in instances where the response from 1,3-beta-D-glucan may interfere with the detection of endotoxin. Enclosed with each kit is the instruction for use, which describes the use of the Pyrochrome kit. You should examine this carefully and be very familiar with its content. Ensure that your Pyros Kinetix Flex tube reader is turned on and equilibrated to 37 degrees Celsius. The LED lights next to each well will be red, and Pyros Kinetix EQS software is in data collection mode. The appropriate parameters for Pyrochrome assay set under test information are as follows. Runtime for a sensitivity of 0.001 EU per ml for both kits is 120 minutes. Chromogenic assay, Pyros Kinetix Flex, appropriate communication port. After establishing communication, set up the well descriptors for negative controls, standard curve, and samples. For this demonstration, we will be performing the assay at a lab bench. A biosafety cabinet is recommended when working with infectious or toxic samples. All of your accessories, including pipettes, pipette tips, and parafilm, should be easily accessible within your workspace. Organize your workspace to allow for easy movement during pipetting, etc. Avoid moving your hands over any open containers. We strongly suggest replacing covers and/or using parafilm as barriers to contamination. In this demonstration, we will point out additional aseptic technique that will help to minimize potential contamination events. Be sure to initial and date all containers to indicate when and by whom they were opened. We recommend using Associates of Cape Cod's 13 by 100 mm borosilicate depyrogenated glass tubes for making dilutions. When opening the foil pack of dilution tubes for CSE dilutions and sample preparations, examine the package to identify the end with the round tube bottom. Carefully open and remove the tubes from the package on this end, and then reclose the package to avoid contamination. Before opening, gently tap the vial of Pyrochrome to cause loose LAL to fall to the bottom of the vial. To open vials of reagent, remove the crimp seal, being careful to avoid sharp edges. To remove this rubber stopper aseptically, a clean 1000 microliter pipette tip can be used. This will minimize any potential contamination. Remove the pipette tip from the box with a micropipette and then remove the pipette tip from the micropipette. Notice that the cover is replaced on the box of pipette tips as soon as the tip is removed to prevent any inadvertent contamination. Firmly grasp the wide end of pipette tip and press the narrow end of the tip against the rubber stopper to remove it. Discard the rubber stopper. It is not reused. Be careful not to contaminate the mouth of the vial. Cover the open vial of reagent with parafilm. When pipetting, always hold the pipette vertically and tip the vial slightly to avoid having your hand directly above the open vial. The pipette tip should be pre-wetted with the liquid 2 to 3 times prior to making any transfers. When ready to make a transfer, slowly depress the plunger of the pipette and then slowly aspirate the required volume from the vial. Pause for a few seconds with the pipette tip slightly below the surface of the liquid to allow the volume to equilibrate in the tip before moving the aliquot to a clean tube. Always pipette slowly and use the blowout feature of the pipette to ensure that the full volume has been transferred. Always use a new tip to measure and to transfer different samples and/or different sample dilutions. Ensure that the side of the parafilm facing the paper backing is the side applied to the top of the vials, test tubes and containers. Ensure that you follow your policy on wearing personal protective equipment. If gloves are required, use unpowdered gloves. Ensure that aseptic techniques are always utilised. The first step in setting up the Pyrochrome assay is the preparation of solution of control standard endotoxin. To prepare the CSE solution, you will use a vial of CSE standard and a bottle of LAL reagent water. Each vial of CSE standard contains 10 nanograms of endotoxin per vial, freeze-dried, and is labelled with a lot number. Before reconstituting CSE, obtain the reconstitution volume of LRW given on the certificate of analysis for the specific Pyrochrome lot CSE lot combination being used. The certificate will give an endotoxin concentration in endotoxin unit per ml for that volume. Certificates are available on ACC's website at www.accciusa.com. Prior to opening the CSE vial, the vial should be initialed and dated. Gently tap the CSE vial. Remove the crimp seal, being careful to avoid sharp edges. Firmly grasp the wide end of pipette tip and press the narrow end of the tip against the rubber stopper to remove it. Using an adjustable pipette or serological pipette, add to the vial of CSE the volume of LAL reagent water specified on the C of A. Discard the tip. Use parafilm to cover the CSE vial. Vortex the CSE vial for 30 to 60 seconds. The CSE has been formulated to go into solution rapidly. Once reconstituted, the vial of CSE may be used for up to 7 days if stored at 2 to 8 degrees Celsius. Next, we will need to prepare the CSE dilutions for standard curve. In this demonstration, we will use a standard curve with the minimum endotoxin concentration of 0.001 EU per ml. This concentration defines the sensitivity of the test. The concentration in the vial of reconstituted CSE is commonly 50 EU per ml. An appropriate dilution of the stock CSE will have to be prepared to achieve 10 EU per ml. In this presentation, we will prepare the first dilution of 10 EU per ml in a 1 to 5 dilution step. We will now prepare 5 depyrogenated dilution tubes and place them in a test tube rack. Open the pack of dilution tubes from the bottom as described earlier. Add the tubes to the test tube rack and place within an easy reach but out of the way of the immediate workspace. The concentrations for the standards can be written on each tube: 10 EU per ml, 1 EU per ml, 0.1 EU per ml, 0.01 EU per ml, and 0.001 EU per ml. As each subsequent standard is a serial 10-fold dilution of the previous concentration, we will be combining the volume of 900 microliters of water and 100 microliters of standard. The volumes may be scaled up as needed according to desired test volume. The first standard will be prepared by combining 200 microliters of 50 EU per ml and 800 microliters of LAL reagent water. Carefully pipette 800 microliters of LRW to the dilution tube labelled as 10 EU per ml. Then change the setting on the micropipette and transfer 900 microliters of water into the 4 remaining dilution tubes labelled 1 EU per ml, 0.1 EU per ml, 0.01 EU per ml, 0.001 EU per ml. After adding water to the tubes, cover the bottle of LRW and set it aside. Vortex the CSE vial for 30 seconds prior to pipetting. Pipette 200 microliters from the CSE stock vial and transfer it to the first dilution tube, labelled as 10 EU per ml. Again, pipette slowly and allow time for the tip to equilibrate in the solution before transferring any volume. If possible, ensure that the tip is in contact with the LRW in the dilution tube when delivering the CSE. The surface tension of the liquid will help to draw out any remnants from the tip. Once done, the tube will have a total volume of 1 ml. Cover the CSE with parafilm. Now vortex the 10 EU per ml tube vigorously for at least 15 seconds. Using the same slow pipetting technique as before, transfer 100 microliters of the 10 EU per ml CSE solution right after vortexing to the tube labelled as 1 EU per ml, and again slowly dispense the volume directly into the LRW. You will note that we did not cover the dilution tubes prior to vortexing. As long as you are careful at keeping your fingers away from the top of the tube, there is no significant risk of contamination. If you wish, you can use parafilm to cover that tube before vortexing. Repeat this process for the 4 remaining tubes labelled 1, 0.1, 0.01 and 0.001 EU per ml, serially diluting the CSE standard each time. When we finish, we have 900 microliters of the 10, 1, 0.1 and 0.01 EU per ml CSE standard. The final tubes of 0.001 EU per ml CSE standard will have a total volume of 1 ml. Prepare a new set of dilutions from the stock endotoxin solution for each test. Do not use the previously prepared and stored solutions. Next, we will prepare the sample. The sample should be prepared according to the method developed in preliminary testing. If testing a particular sample for the first time, a series of dilutions of the sample down to the maximum valid dilution can be set up. The appropriate dilution of the sample should be prepared in LRW, unless validated otherwise. The pH of the sample lysate reaction mixture should be within the range of 6 to 8. In this demonstration, we will test a sample of clean water. For each sample or dilution of sample, also include parallel positive product controls. Samples spiked to give a concentration of endotoxin at or near the middle of the standard series without significantly diluting the sample. There are different approaches for the preparation of positive product controls. One of them is hot spiking the sample with concentrated endotoxin solution. We will spike 1 ml of undiluted water sample with 10 microliters of 10 EU per ml CSE concentration, creating water spiked with 0.1 EU per ml. Now we will transfer the negative controls and CSE dilutions into the reaction tubes. Be sure to keep your workspace well organised. Use borosilicate depyrogenated test tubes as reaction tubes. Each pack of tubes is labelled with a lot number and an expiration date that should be recorded. Take care when opening the pack and remove tubes with the bottoms facing up. Pick up each reaction tube in the middle to avoid contamination. Add the tubes to the rack supplied with the Pyros Kinetix Flex, one by one, and place the rack within easy reach, but out of the way of the immediate workspace. Minimize the handling of the tubes to prevent contamination. Tubes remain uncovered, thus utilize extreme caution not to contaminate them. A lysate to sample ratio for tests in Pyros Kinetix Flex tube reader is either 1:1 or 1:4. In this demonstration, we use the economical ratio of 1:4, using a volume of 200 microliters of sample. Use the open bottle of LAL reagent water for the negative controls. Transfer 200 microliters of LRW to the negative control tubes in at least duplicate, for reagent qualification in triplicate. Avoid working over the open reaction tubes. Vortex each CSE standard for at least 15 seconds immediately before transferring 200 microliters of the standard to the designated reaction tubes in at least duplicate. For method, reagent, or technician qualification, use triplicates. It may be helpful to start with the lowest concentration and move towards the highest concentration. Again, take your time and pipette slowly to avoid errors, pausing after aspirating the liquid. Allow the pipette tip to contact the inner wall of the tube, which ensures efficient transfer of the solution. Since the reaction tubes are not labelled, it is important to remember the exact location of each standard. Each dilution tube containing the CSE standard is covered with parafilm after it has been pipetted. Now we are ready to transfer the sample into the reaction tubes. Vortex your sample for 10 to 15 seconds. Carefully and slowly transfer 200 microliters of each sample replicate to their designated tubes using the same technique as described previously for standards. Allow the pipette tip to contact the inner wall of the tube, which ensures an efficient transfer of the sample. Some samples may be viscous, and rapid pipetting may result in incomplete transfers and poor precision. Change tips between different types, dilutions of the sample. Samples are generally tested in duplicate, but we encourage new users of the test to set up their assays in triplicate until they have demonstrated a degree of proficiency with the test. To avoid contamination, keep the rack with the reaction tubes away from any source of contamination. Now we are ready to reconstitute Pyrochrome reagent with the appropriate buffer. This is Pyrochrome reconstitution buffer for the C1500 kit, or Glucoshield buffer provided with the CG1500 kit. Label and date a vial of Pyrochrome reagent. The maximum sensitivity using both combinations is 0.001 EU per ml in the Pyros Kinetix Flex tube reader. In this demonstration, we will reconstitute Pyrochrome with Glucoshield buffer. Carefully remove the aluminum crimp caps from each of the Pyrochrome reagent and buffer vials. Remove the rubber stoppers using a separate pipette tip for each vial as shown. After rinsing the tip with buffer to equalize surface tension, carefully pipette 3.2 ml of the Glucoshield buffer to the Pyrochrome reagent. One way to add 3.2 ml of buffer is to set your 1000 microliter pipette to 800 microliters and transfer 4 volumes of buffer to the vial of Pyrochrome reagent. Dispose of the tip. Cover the vial of Pyrochrome reagent with parafilm and gently mix as demonstrated. Do not vortex Pyrochrome under any circumstances. Set the reagent aside at room temperature for use later. The lyophilized pellet may take a few minutes to go into solution. Therefore, rehydrate the Pyrochrome reagent at least 5 minutes prior to use. Once reconstituted, Pyrochrome reagent may be stored for up to 8 hours when stored at 2 to 8 degrees Celsius. Do not freeze reconstituted Pyrochrome. Once all the controls and samples have been added to the reaction tubes and the Pyrochrome reagent is fully dissolved in the buffer, we're ready to add the Pyrochrome reagent to the reaction tubes. For this step, we'll use a repeating pipette with a sterile syringe tip. The tip for the repeating pipette is kept in a sterile bag. When the tip is placed onto the pipette, make sure not to touch or contaminate the tip. Ensure that your repeating pipette is set to deliver 50 microliters. This will be a function of the size of the tip. Use the information printed on the side of the tip to obtain the appropriate setting of your repeating pipette. Before dispensing any of the Pyrochrome reagent, it is good laboratory practice, but not required, to rinse the syringe tip twice with LRW, discarding the contents each time. If the tip has been rinsed with LRW, ensure all the water has been expelled and draw up the Pyrochrome reagent. Then point the tip against the inside wall of the vial and expel the reagent slowly back into the vial to gently mix it. Performing this step too quickly can cause undesirable foaming of the reagent. Then slowly draw up the Pyrochrome reagent again. Eject 1 volume of the reagent back into the reagent vial before adding Pyrochrome reagent to the first reaction tube. Check the instrument and the software setup. Add a 50 microliter aliquot of Pyrochrome reagent to the first negative control tube. It may be helpful to add the reagent with the pipette aiming at 45 degrees against the inner wall of the tube. Do not touch the tube with the tip. Then grasp the tube between your thumb and index finger, touching only the middle section of the tube. Vortex the reaction mixer in the tube for approximately 2 seconds and immediately place the tube into the designated well number 1, in the tube reader. Make sure that the tube is pushed all the way down in the instrument. On the instrument, the LED light for well number 1 will change from red to green when the tube in the reader is recognised. In the software, the field for well number 1 in the OD column will turn yellow and will display zeroing. This may take a few seconds. This confirms the communication between the instrument and the software. Once the communication is confirmed, we can continue in the same fashion with adding all of the remaining reaction tubes, negative controls, standards, and samples. Always proceeding one tube at a time, adding the Pyrochrome reagent, vortexing for 2 seconds, and placing the tube in the reader. You can hold the repeating pipette in one hand the entire time. Avoid contamination of the tip and work away from the open tubes. Use your opposite hand to handle the reaction tubes. Make sure that you fill the syringe tip with an appropriate volume to avoid running out of the Pyrochrome reagent in the middle of addition to a tube. You may refill the syringe partway through the reaction tubes. Take care not to contaminate the tip, the Pyrochrome reagent, or the reaction tubes. The Pyros EQS software allows viewing the OD readings for each well individually. There are different formats in which it is possible to view the data while in data collection mode. This is accessible via the View tab on the main screen. In a graphic circle, this screen allows the user to see which wells have tubes inserted in them and, for each well with a tube, see mini plots of the reaction on this screen itself. It's possible to enlarge the plots individually or to view the plots of several selected wells. Numerical data. The option allows viewing the data block of raw AD values and temperature for the last reading recorded by the software. Standard curve regression plot. This option allows plotting the selected curve after all the replicates reached the onset and the curve has completed. This is an example of what the Pyros EQS software displays for a typical Pyrochrome test. You can observe the kinetics changing as readings are taken. At the end of the runtime, the software will automatically terminate data collection and switch to analysis mode using the onset OD of 30 milliabsorbents. The data is then displayed in different types of reports: data summary, individual well report, individual sample report, pass-fail report. Then the reaction tubes are removed and disposed of appropriately. This video is a demonstration of the steps needed to conduct a successful Pyrochrome kinetic assay in the Pyros Kinetix Flex tube reader. Careful attention to the procedures that you have observed will assist in performing the test. Becoming proficient is a matter of practice and attention to detail. Upon completion of an assay, please refer to the Pyrochrome instructions for use for information on how to interpret the data. We hope that the preceding video has provided useful information that will help you perform the kinetic Pyrochrome assay in a tube reader successfully. If you have any questions or want any additional information on any aspect of the assay, please contact Associates of Cape Cod's Technical Services Department, either by phone at 508-540-3444 or by email at techservice@accciusa.com. We encourage you to call before you start testing. We want you to be successful with Pyrochrome and will make every effort to assist you.